Hello community, so great that you're here. Today we do something fun. We build a single task R2 system. And you might ask why? Because we do have the base model. We do have the new DeepSeek version 3 published here March 24, and this is amazing. It is open source. So, you remember? Now this new version 3 has improved reasoning capabilities. Here, if you look at a different benchmark, but what I'm really interested is a single task. So, even if we look here at coding, here the ADA benchmark here, the DeepSeek version 3, now even the new version is here, shortly behind the DeepSeek R1, but never mind, because I want to improve this DeepSeek version 3 significantly for my task. Yeah, of course, look at the new Gemini 2.5 Pro. Isn't it amazing, the distance even to Claude 3.7 Sonnet syncing? Wow, it's from 64 to 73%. This is impressive, but we are focusing here on our little DeepSeek version 3 update, and you might ask why. Look, the top 10 AI systems on this planet currently, there's only one that has an open MIT license, and this is DeepSeek R1. And therefore, I will focus my effort on an open source model. Let's have a look. If I look here at a different benchmark, I think this was interesting because, this was here the old DeepSeek version 3. And now this here is the jump, the performance jump in the Artificial Analysis Intelligence Index here. And this is the new version 3. And if you look here in blue, you see here DeepSeek R1. And you might guess, so where would R2 bring us? No, but this wasn't it. You know what was here the nucleus for this video? I read the best non-reasoning model today on the planet is DeepSeek version 3, 0324. And I thought, non-reasoning? Yeah, test time compute scaling. Non-reasoning. And a spark of genius. Yes, of course, you know it. Because I thought, I do my elevator test. I do this test now for 11 months. This is the test. And I do it here on every new LLM model. Here, for example, you have Claude Sonnet 3.7 here in the syncing 32K or Grok. So this is a benchmark, and I always do it here on the chatbot arena lmsys.org. And we choose here our DeepSeek version 3, the latest update. You know what? Let's go live. So now we are live and we are here with the direct chat, and we select here our beautiful DeepSeek version 3. I input here my test, and here we go. We're running live. It is accelerated. I just want to show you in the first run, it really tries to find here a solution, but I can tell you here, unfortunately, even trying here the best, it is not able to find in the first run here a real solution, because what we come up with is a 10-step solution, which is not the optimal way. So it is easy. Now, this new DeepSeek version 3, it failed in the first run, but that was to be expected because it is not the R2 version. This is just the base model for the R2 version. But you know what? If this is the best non-reasoning model, do you know this brand new idea? What if I update it to a reasoning model? Of course, I cannot afford this here for the complete model, but for one single task, I will do it manually. And you know what? The task is my elevator test. You remember this video where I showed you AI agents here, where we have the test time compute reasoning and test time compute scaling and inference compute. And this is the reasoning model part, if you want, no? So we do have here branching out of multiple different causal pathways. We arrive at a final answer. We have a final reward signal at the end of the thinking process. And then we built here, in this particular case, a Monte Carlo tree search algorithm. And then we decided, you know what? We want an internal step-by-step process reward model. And this is exactly what I'm going to do now for one single task only. And I will use my brain, my human brain, for exactly the process reward model and for the branching out. And you know what? It is simple. We can do this together. Let's have a look. The core element of all of this is we do have the new DeepSeek version 3, the improved, better reasoning performance, and we know it's the base model for the next iteration of R1. So what we do, I will do here in this video here, the complete movement from the non-reasoning part to the reasoning path. So I will kind of upgrade the DeepSeek version 3 0324 to the R2 model for exactly this task. And doing so, we will have some very interesting facts happening here. So let me show you what I discover. Just in case you say, I'm not sure that you can do this. You remember the old DeepSeek R1? Wasn't it beautiful? Look, 1.5 million downloads here for the full version. But you remember they told us here the DeepSeek R10 and the R1 are trained based on the DeepSeek version 3 base model. And now we have the new base model. So great. And you know what? I have a particular video where I showed you how to create here this DeepSeek R1 and R1 distilled in Q1, everything explained about them. Or if you do not trust my videos, go validate, go to Chatbot Arena and ask here in the arena, in the battle modus, hey, how was DeepSeek R1 trained on a base model DeepSeek version 3? Explain here the training steps. And then you have here two best models currently available for free of charge. And you see, yeah, I remember, no? As I've shown you in my video, supervised fine-tuning, reinforcement learning for reasoning, rejection sampling, and supervised fine-tuning for particular traces. So let's do this manually. And here we go. So I'm branching out now. I say find an algorithm, you see? Find a different algorithm. And yeah, beautiful. It comes up with a gorgeous one. It does here the Python coding. You have to read this in real time. You have to understand it. You have to guide the system. Then I say branch out, find a more abstract solution because I've seen what it done with the code. Okay, abstract button algebra. This is really nice. Have a look at this. It's accelerated 10 times. So this whole branching will take us just 3 minutes to watch, but it took me more than 30 minutes to read every line, understand it, evaluate it, and can come back with a new branching strategy. So here we have now an 8-press solution. Now, isn't this fantastic? I say, do better, improve. I say, okay, let's go. And as you can see, it tries now another solution, path forward. Can we reach this final solution? No 7-step exists. I say, transcribe the algebraic idea that I saw that it tried. And look at this. Isn't this beautiful? Then exploit different button has a hybrid strategy, and it comes back and says, it's really winning a 7-step strategy. 7-step, why this works, conclusion. Hey, and I say explore other option now that you have this algebraic. And it goes on, and you have to branch out, you have to read this, you have to evaluate this, and you have to come up with a new branching idea. Normally this is done by reinforcement learning, of course, and reward functions. You say, okay, retro-engineer solution. Why not do this, no? Let's start at the end and just go back here to the beginning, and maybe this will help the system to be much, much faster, as you can see. Trying to do this finds now kind of another logical path, retrospective here, for looking at the alternative, combining different buttons. You remember we only have 5 buttons to press on the elevator, and we want here a 6-step solution. It says discovering a 6-step solution. No. Still short. No. Unfortunately, no. I said start at the end. So maybe retro was a little bit too complicated, so it tries to start at the end, subtracts everything. Okay, so tries here to find a winning strategy, the shortest path backward. You see it tries here from different here levels to come down. There's a different strategy if you have a look at this in detail. So you do have to have a process reward system running in your human brain. Final answer, the shortest path, 6-step solution. Yes, do we have it? No 6-step solution exists. It fails here to find a 6-step solution. Well, that's a pity. What is absolutely necessary for this exercise to work? We have to validate that this new DeepSeek version 30324 is self-reflective and self-corrective. And we did it. Believe me, I checked for this in particular, and yes, this is it, so we can continue. Now, interestingly, there's one problem I encounter if I read here all the reasoning traces in the branching out. So I'm here, if you wanted a Monte Carlo tree search algorithm, I noticed there are some calculated pre-assumptions from the very first run of the AI system that are so deep in the system, I can't break them. And I said, how is this possible? I imagine this in the following way. So we have here a pre-training or a supervised fine-tuning or a reinforcement learning or a DPO, whatever. Then we have here the inference run. We have here our incoming query. And now in the very first run of the non-reasoning model, interestingly, we have here that the model itself decides there is now a pre-assumption A1. And this pre-assumption, I will show you, has something to do with the risk assessment of this of one of the particular 5 buttons. And then branching out, there's also some pre-assumption of the AI system that are not clearly visible to me. But even if I see them and I tell the system, hey, change your pre-assumption, I'm not able to break those. So interestingly, in this methodology, whenever you just have a classical non-reasoning system here, there are, in the first run, the system determines some absolute determinants in its decision-making process, in its reasoning process, that determine the complete afterward system. And I say, alter now your initial conditions. And it tries to do this, no? But it's not really working because look at what the system is doing. Final 6-step solution. It think it has it, but then no. No key insight, no optimal solution, no verify, no. Also testing, there's only a 7-step solution. I say, show me your initial conditions. I want to understand what are those initial conditions that it is stuck. Look at this, so nicely done. But it cannot overcome, even with BFS methodology, its initial condition. Look. Say, change your risk assumption. And now I think I'm onto something. Because look, this is now a much better algorithm. Why the 6-step solution with calculated risk, it alters its internal risk assessment. And now, if I say run again, something happens. It finds a loophole. Look, correct 6-step solution found. How it works, goal achieved. Okay, and you see, strict interpretation is enforced. So it says now, I alter my instruction. I have a flexibility in the interpretation because you see, under flexible next multiple, I can do it, but under strict rules, I still fail. So when I told the system, hey, change your risk assumption, no? Go high risk, include maximum risk. You see the answer, yeah? To push for a 6-step solution, we will embrace now the maximum risk by prioritizing now high jump buttons, A and C. Then really triggering the traps if recovery is possible. Using here the button A, explosive growth, even if the system has a very high risk aversity for button A, and exploiting now button C bounce effect from the prime numbers for some massive gains. So you see, the system decided somehow in the first runs that those are critical risk factors and to stay away from them. And this is amazing. I never thought that they would be so persistent in the memory here of this AI. So now I tell him, hey, buddy, here's the solution. Look, check this solution. This is a 6-step solution. And now let's have a look. It is rather skeptical, the system. Now it says, okay, step-by-step evaluation, start at floor 0, floor 3, floor 7, floor 11. Tries here to implement this because it tried more than 45 minutes to find a solution and it failed. No? Verification, reached in exactly 6 moves. Why this works? Okay, comparison, yeah, is more efficient than the previous found 7-step solution. Final answer, valid 6-step solution found. Isn't this beautiful? I say, analyze now your logic mistake. And now we learn, the system learn, and this is now important for us. I say, pinpoint exactly your logical error. And take some time and said, why I missed here the 6-step solution, over prioritizing here a specific risk assessment of one button. Button D is conservative. While it will ensure progress, it's slow, misjudging the button's A, risk assessment, underutilizing button B, flexibility. I treated button B as the last resort, and this was wrong. 4, it was overlooking a compound growth assessment. So the corrected approach is test all button combinations, leverage compound effect, and question all the assumptions. So just make sure that this is really a 6-step solution. Look, that's okay. Oh, we hit here the limiter. So do we have no? It's okay. 6-step solution. Final answer. Use A and B in tandem for exponential growth. Minimize the button D. Avoid the traps. So let's have maybe a detailed last look. So I asked the system, as I've just shown you, hey, pinpoint exactly your logical error. Look at this, over-prioritizing a particular button. There was a specific risk assessment inherent in the first run. Why it was wrong, button D is conservative. While it ensures progress, it is slow. The winning sequence uses D only twice for the first and the last move, freeing other steps for explosive growth via button A and button B. The misjudgment of the button A, risk. This shows you this inherent assessment that is happening. Why AI was wrong, button A is high risk only at certain floors. At others, it is penalty free and it is a powerful approach to utilize. Underutilizing now button B's flexibility was another mistake by the AI. It treated button B as the last resort due to its conditional subtraction. Missing that in a particular combination, it is a real powerful tool. So you see, it was just looking at specific button in isolation. It was not going here strategically for a sequence of buttons and analyzing their particular power and their advantages. Overlooking compound growth. I think this was the biggest mistake by the AI system. AI comes back and says, I evaluated buttons in isolation, not how they compound. ABA creates here a growth engine. And this synergy was invisible when testing here the buttons individually. And you might say, how is this possible? Do you have an elevator with only 5 buttons? Why is it not possible that here one of the latest AI system is not able to, if you want, have a risk assessment of a sequence of button presses? Why is it trying it out and look at it in isolation? But it found out that this was a mistake and comes back and says the sequence power comes from chaining A and B to exploit their combined scaling. Really interesting to see this. And then, of course, I went on and I wanted to create now the solution template. I wanted to create now, with all the insight what went wrong. So I was, if you want, the human reward function. I evaluated all the different branching out. I identified the branches that were correct, the sub-branches that could theoretically lead to the correct answer, although maybe it led here in the complete process reward system to the wrong answer. And now I guide here the AI to come up with the solution template. And I say, now write a new prompt for yourself next time to avoid your mistakes in the next run. Be direct, be explicit, define a general solution path what you learned in our conversation. You should be able to master the next similar task in the next run, and then we have a discussion. But the most important fact is it comes then with an universal solution protocol. Look at those. Step 1, step 2, step 3, step 4. So beautiful. This is the core of the whole almost 1 hour long discussion with the AI system. Step 1, model the problem in a mathematical way if it's possible. For each action, define its state transition function. Identify critical properties of the state. Then, classify the action by its behavior. Look at this. This is a strategic insight we received after almost an hour. We have different growth actions. We have an exponential growth in a particular sequence of buttons. We have a linear growth in use when minimal steps are prioritized. Now we have different growth strategy that will be implemented. And for the high risk action, deploy only when the rewards outweigh here our risks. So when we need large leaps forward in our solution. Mathematically, different growth actions, different risk assessment. Aggressive growth phase should be now a hybrid search strategy for the next AI system. So for the R2, R2 would now take this as its, if you want, reasoning result and then run the query. So we did here a manual R2 for only a very single task, but those are the insights that now enable here a theoretical R2 system to find a solution. And we have the insight what went wrong in the base model DeepSeek version 3.03.24. Chain here the growth action. So nice. Exponential linear to maximize here the progress. Have here exploit here the compounding effects in our strategy. Use alignment actions to fine-tune the proximity to the goal. So nice. This is here the main insight of the system. So if you want here this solution protocol generated here by our new DeepSeek, I just put this, if you want, in the next system prompt when I have here a new query. And this is here, if you want, a solution prompt generated by a reasoning model template as generated by the tree branching and human reward function estimations we did together here manually. But you know what? We achieved exactly what a single task R2 functionality would do. We were the reward system. We looked here at a process reward functionality. We evaluated each and every step. We evaluated different branching options here for a tree structure in our reasoning models. And we had a self-reflection and a self-correction and a self-learning methodology for the model, for the next exercise of the model. And you know what? And now Claude Sonnet, this thinking tool, comes in perfectly. You know what? This solution protocol is now exactly why, if we would use Sonnet here, what we would put in this thinking tool. Do you remember? It's more than a scratch pad. Because if we put this in the thinking tool, and you know, in my video I showed you here what it is here in the example, the thinking tool we use here lists the specific rules. We just have found here for the elevator, this specific rules. Check if all required information is available, verify that the planned action complies with all the different policies, and iterative here over the tool results for the correctness. And then you see this is here the function of the scratch, but we want to implement the solution policy. And now the template itself we would insert here for one particular task. And my particular task would now be not user wants to cancel a flight A, B, C, but now user wants to find here the shortest sequence of button presses in an elevator to solve the logical test. And then I would have here exactly my solution protocol. So this. Isn't this beautiful? It is a pure temporal coincidence that just one of my last videos were about here this new thinking tool by Sonnet, but now you understand why Claude or Anthropic decided they need this tool and they implemented this tool in their Claude models. And now we can manually implement it now in our R2 functionality, in our single task functionality. In this video, I showed you here a little bit more complex instruction here, a solution protocol, or think about you want to do your financial calculations. Think you have a portfolio and you could either trust now the latest AI system, or you say, hey, listen, buddy, I know exactly what I'm looking for. I know exactly my financial calculation, my risk assessment methodology, my risk, thresholds that I don't want to override. So you can now create your own solution template for, let's say, your financial, for your medical, for your, driving, machinery, whatever you have, and then say, this is now here if you want the reasoning step to increase the performance of your system. So you see, just for my intention, hey, I just have a look at DeepSeek version 303.24, the new DeepSeek here that will be the base model for R2. Step by step, I discovered, it would be fun just to try out an experiment. Hey, can we do a single task R2 functionality? Let's have a look if we can do this manually for only one single task, my elevator. And what a coincidence, it was kind of working. We found a solution. But you know what? There's a fringe benefit to this. Because guess what? Now that I have a solution template for a very specific problem that even the biggest AI systems cannot solve in the first run, I can now use this solution template for smaller models. And maybe in my next step, I will build now a 3 billion LLM with my solution problems for this single task elevator test. And I would love if my new 3B model with the solution template would achieve something even the best and the, amazing, the huge LLMs all fail to perform in the first run. So you see, let's try it out. Let's find new solution. It can be fun. I hope you enjoyed this video. There was some new information. Hey, and if you subscribe, wow, I'm looking forward here to my next video.